So thank you for coming to the session with the most complicated name, I guess. I'll talk about different clouds. We'll start from myself, right? I don't want to talk about all these pictures here, but point is that as of today, I'm a product manager at INFINIDAT. And I show this because actually I care, but don't want to talk about this. What is INFINIDAT, right? And I have to talk about this as well because they pay me. But most of the presentation won't be about INFINIDAT, it will be about other things. So in general, INFINIDAT is a high-end storage vendor. We provide hybrid storage systems, large-scale, high-performance, high-capacity, highly available. Actually, glad to see a couple of customers here in the room. We exist since 2011, and as of today, we have shipped over 5 exabytes of capacity in the field. Most of our customers are large enterprises, financial institutions, banks, insurance companies, and so on. Our main product is this hybrid storage array, InfiniBox, which can host over 4 petabytes of capacity. And we added to this few other offerings with the backup solution and the storage offering, storage service offering, and so on. We are not going to talk about it here. What we are going to talk about is really looking into the solutions that are offered today natively by major public clouds. Right. I'll touch on some of the solutions from probably 5 top hyperscalers, right? Looking into functionality, looking into performance, looking into the pricing. And I want to look at this, first of all, not on all kinds of offerings that they have in the storage space, but things that are specifically relevant for traditional enterprise customers. So the same customers who usually buy storage from companies like us on-prem, and when they think to go to the public cloud, what kind of challenges they see. So I am not going to touch things that are relevant for like platform as a service offerings. I'm not going to talk about things like BigQuery or Data Lake from Azure that was covered in the previous session. I'm covering specifically the block storage and file and a little bit on object. And again, the discussion will be from the point of view of the traditional enterprise that runs an OLTP type of application or any other large-scale enterprise application on-prem and things to move to the cloud. And that's kind of an agenda. I'll start from the key takeaway, and the thing that we see, and both from studying what is available with public clouds and when we talk to our customers, is that yes, there are plenty of offerings from all the public major hyperscalers, but they are not necessarily suitable or sufficient today for lift and shift of the enterprise applications going into the cloud. Yes, the applications that are developed from scratch, cloud native, they get great solutions in the cloud. Things that are native, were on-prem, may not be as successful if they just moved as is. So let's look on some examples. If we look on the block storage, start from that offering. Any hyperscaler obviously have the block storage offering today with different names, Elastic Block Storage with Amazon, Azure Managed Disks, Persistent Disks with Google, and so on. Right? All of them have some limitations. It's all published, available on the web. You can create a LAN, essentially a block storage, somewhere between 16 to 64 terabytes, depending on the vendor. Again, we see cases when customers do create on-prem LANs that are much bigger, but I don't think this is a big limitation from their point of view, but that's available. Another thing that is kind of a basic functionality that we see is snapshots, an ability to take a snapshot of your production LAN and then do something with the snapshot. So yes, snapshots are used for backup, for example, yeah, and that works perfectly well in the public clouds as well. You take a snapshot of an EBS volume in Amazon and get the copy of the data in S3, and then you can use it to recreate a new EBS volume out of this data. But you can't take the snapshot and use it without creating a new EBS volume. Same thing exists in all other major public clouds. Yes, you have your copy elsewhere, but you can't use this copy without recreating this EBS volume or persistent disk. Availability. So there is an SLA published. There is a difference in all major public clouds between the availability and durability. There was a nice discussion yesterday with the EFS team talking about this with some questions. But definitely durability is critical for customers, but in the enterprise space, we see demand for availability as well. And commitment to get something that is highly available, not only durable, but also available all the time, is very important. And definitely offerings like 4 nines or 5 nines is less sufficient for some of the workloads. They all have different tiers of media for different purposes, SSD-based, HDD-based, but again, the customer usually has to decide upfront what kind of media is needed depending on the workload, which provides some extra confusion points. Obviously, everyone has encryption. So looking on the basic functionality, everything seems to be OK. But if we go more into things that are more advanced and more applicable for the enterprise applications, before we do that, a step back. We talk about availability, right? And there are all those commitments about 4 nines or 5 nines. There are things that happen and sometimes unplanned, like some recent issue with Amazon, or even sometimes things planned. If I go, this is a real email which I got like yesterday from one of the public cloud providers that tells me what I have to do with my cloud-based LANs. That's really weird. So this is not something that commonly happens, but apparently it does. So yes, there are SLAs, there are commitments, but interesting things happen. So talking about the enterprise functionality, right? What I listed here is things that we hear very often from our production customers running the enterprise applications on-prem, what features they care about when they talk about the block storage. They are doing multi-touch setups, so basically clustered applications running on multiple hosts on-prem, sharing the same LAN. This is not possible in most of the major clouds. Taking an ability to take a read-write snapshot. We talked about the snapshots in general, the read-only snapshots. Right? I can take a snapshot, copy, the data gets in public cloud, the data gets copied to object storage, and then it can be used only to restore. There is no option at all, in most of the cases, to do a read-write snapshot. Right? So on-prem customers can take a snapshot of the data that does not consume space, very efficient. You make it writable. You can mount the snapshot and run, for example, your test and dev environment on this. And you can provision those test and dev environments and create these clones or read-write snapshots instantly on enterprise storage systems. This is not something that you would see in the public cloud. Running a complex application that requires consistent snapshots across multiple LANs is usually also not available. Things like replication. Yes, there are some examples where we can find that, especially with Azure, that provide extra reliability. You can do geo-level replication or zone-level replication that meets those requirements of async or sync replication from customers. However, most of the public clouds, again, do not provide those solutions, at least not natively. Thin provisioning, things that are used by the customers to reduce the cost of storage. Again, thin provisioning or compression or deduplication or all those features not available in the major public clouds, or at least not exposed to the customer. I'm sure the hyperscalers do leverage this to reduce their own cost of operation. At least some of them do, but it's not something that customers may use. And an ability to provide sharing of the data between different sites within on-prem and off-prem. I probably had to use a different color here. It is possible to access your data at the cloud, but you can't really do any kind of replication between on-prem and your cloud environments, or any kind of other sharing between those LANs in one place and another. Let's look on performance. So I was running some basic tests using VDBench and used different instances in different public clouds and different types of volumes. So what you can see here is 4 kilobyte random reads. This is the latency, right, in milliseconds. 4 kilobyte random writes, 64 kilobyte read, and 64 kilobyte writes. And we can see that there are some major differences in the performance and the latency that we can get. This varies between the different types of instances, different systems. This varies between different clouds. But in most of the cases, it goes in milliseconds. There are some exceptions with some optimizations. For example, with Azure Managed Disk, you can create local caching for reads and writes. And depending on the workload, the latency may go significantly lower. But in general, the latency is in milliseconds. One thing that is interesting with Google specifically is the difference between a single LAN and multiple LANs mounted on the same instance. So in Google Cloud, when you mount a volume to an instance, it gets some allocated bandwidth and IOPS that can be utilized. If you mount, and this is usually true for any public cloud, right? So you get your LAN, and you get X IOPS for that LAN. If you get 2 LANs, then you get X IOPS per each LAN. With Google, this capacity is added together. So what you can see in this test, and the last one, is I have a Google instance. I create 8 LANs, mounted them to the same instance, but I still run my benchmark against single LAN. I'm getting much better performance, 8 times better performance than running the same test against a single LAN mounted on the same instance. Because the overall amount of IOPS and bandwidth available for all those LANs mounted is kind of summed together. And if I use only single LAN, I still get better performance. So just an interesting finding. Same test looking on the IOPS, right? Depending on the cloud provider, the Azure goes way above everybody because the volume here has read caching enabled. So basically, the data does not go all the way to the remote disk. But again, it depends on the workload, whether the workload would benefit from it or not. And the throughput as well. Now, things that are cut here, we'll talk about this soon. What kind of limitations you may expect when you run the performance in the public cloud. And those limitations may come from multiple aspects. But let's look, before we talk about performance and limitations for performance, let's look at the price. All right, so many people, when I talk to them, they believe that the price of the storage in the cloud is relatively cheap, which is not necessarily true. So this is, I tried to put here some kind of comparison between the price of the block storage from different public clouds and split it into tiers of kind of top tier SSD, low tier SSD, top tier HDD, low tier HDD. It's not exactly apples to apples because different clouds really see what does top performance or low performance tier mean. But it gives some kind of understanding of what we have here. And we're talking about, depending on the cloud provider, different amounts of cents. This is in, basically, most of them are talking about over 10 cents a gig, 12 cents a gig a month for capacity. I did not look here on Azure, recently announced Azure Ultra disks that provide much higher performance than the regular disks, but also cost a lot. I also do not take into consideration here the charges that you can get beyond the capacity. So for example, if you go with provisioned IOPS in Amazon, EBS, you pay not only for capacity used, but also pay for the IOPS. All right, so this is not included here. Now, let's make this converted into the way the enterprise look on the cost of the storage. All right, the enterprise usually do not buy OPEX. They buy CAPEX, and they buy upfront. So let's say I'm an enterprise and I want to buy 1 petabyte of capacity, and I want to buy it for 3 years service. This is what I'm going to pay using the same price. Yes, there are some discounts that you may get if you buy from this scale from the public cloud, but it's not that significant, right? So it's anywhere for this 1 petabyte usable over 3 years. We're talking about somewhere about $4 million for a petabyte, or $4,000 a terabyte. That's quite a lot, even though it includes things like the TCO, right? Not only the acquisition cost of the storage array, but also all the operation and service by Amazon and power and cooling and so on. Still, this is significantly higher than buying storage on-prem in most of the cases. So to summarize this block storage review, there are different solutions that are available from different clouds. There are some similarities on kind of tiers and types of storage available. It's usually media defined. You have to choose if you want to go with spinning disks or SSDs. Sometimes you can do easy transition, like with elastic volumes on Amazon. Sometimes it's more complicated. Performance that you can expect per disk really varies, and it depends on many, many things. There are different limitations in different public cloud providers. Sometimes it can be limited by the maximum throughput of the instance. Sometimes it's limited by things like maximum volume throughput, storage account limitations in Azure, number of attached drives, and so on. So switching from cloud A to cloud B is not as simple when you look into storage. You have to really understand what kind of limitations are out there and what kind of performance you may get. Also, talking about performance, we saw that we're not able to get somewhere above half gigabyte a second throughput per instance unless you go to some really big instances in the public cloud, which may or may not be a limitation for some of the applications. Talking about availability, well, we saw some of those examples with EBS volumes being lost, or the IBM cloud email, and that's just recent examples. What happened to it? And there are other things, right? So SLAs are relatively low comparing to the enterprise expectations. No multi-path, no replication. Basic functionality is obviously there. Enterprise functionality is less common. And it's more expensive than usually see. Yeah?
So isn't it like the most fundamental property of the cloud storage that you don't have to pay upfront? So then if you, like, imagine that the same 1 petabyte usable over 3 years will be like the first year you use only a quarter of it, then the second year you use a little bit more, and then by the end of 3 years, yes, you use 1 petabyte, but you don't pay for the whole petabyte for the during the first 2 years.
Yes and no. So first of all, there are storage vendors like us who provide also the kind of gradual growth of the capacity. You may get like capacity on demand on-prem, and you do not pay for the entire capacity of your rack upfront. You can grow it also. And in general, I usually see that when a customer buys a petabyte of storage, it's not that he's starting to use the last quarter of it in the 5th year. It usually gets full pretty quickly. So it's usually migration of data from some other legacy storage that is out of warranty. Okay. Yep.
So there pretty clearly all the people costs, or almost all the people costs, for all the storage administrators, et cetera, are rolled into the cloud costs. They're not in your on-prem costs.
That's why I'm not comparing it one-to-one to the acquisition cost. It's definitely not all. Now, one thing that is important to understand, yes, there are things like you don't need to install the system, and you don't need the technicians to go and replace drives, but you still need a storage administrator to manage those EBS disks in the cloud. And somebody has to understand what storage you need and what kind of EBS disk you need. So you do need maybe less skilled people in your data center, but you still need highly skilled storage engineers to support large-scale storage environment, even if you're running in the public cloud. So somebody who would understand all those options in EBS and all those options in Amazon and in Azure and so on.
I can tell you that I've heard customers tell me, it's worth a lot of money to me to get rid of my fiber channel prima donnas or whatever, insert whatever term you wish.
Sure, but he needs to replace them with somebody who would be knowledgeable in Google persistent disks or EBS volumes. Now, another thing that is interesting if I look at this is the way the public clouds look at the storage in general, and the block storage specifically. So for example, if I look on Azure console, right, and there is no way to take a view on all my persistent disks in Azure. Right? So there is definitely a console view on my storage accounts and blobs and file systems. But if I want to see a list of my persistent disks, or managed disks as they call it, there is no single view on that. So the view on the block volumes in Azure goes through the view of the virtual machines for the instances. I can go to the instance and then see all the LANs attached to this instance. But there is no view for the storage administrator. So that's an interesting approach to this. And it's not common to all of them, but it's interesting to compare how, I guess, product managers in Azure define things as opposed to product managers in Amazon or Google. OK, file storage. So again, looking on managed file systems, and this is a relatively new addition. So I think when all the public cloud providers came to existence, the file systems in general, hosted file systems were afterthought, right? So S3 was the first thing that came with Amazon, or object storage in general with others. Block storage was necessary to run the virtual machines. The file storage is something that is not native as a relatively new addition. But today, all of them have something. So the Elastic file system with Amazon, the Azure files with Azure, the file store in Google, and so on. Again, it's interesting to compare the basic things. Size-wise, right, some of them have essentially no limits. Again, it was an interesting conversation yesterday about the EFS thing, which may create some issues, by the way. I was mentioning this yesterday. I was playing with the EFS when it was in beta version. And yes, you create an EFS file system, you mount it on an instance, you do DF on that file system, it returns 8 exabytes of the size. Now, some applications that you run fail because they say you have negative size of the file system, right? Because it's kind of bigger than. I think it's addressed now, but it was an interesting experience back a few years ago. Others have much smaller limitation to the capacity, right? 64 terabytes or 12 terabytes in IBM, or 5 terabytes in Azure. I think Azure is doing some preview now for 100 TB file systems, but that's relatively small. Snapshots. Snapshots are very important for enterprise customers, right? An ability, I think some of the NAS vendors like NetApp did a great job introducing this access to the snapshot through the data path. So things like .snapshot or .checkpoint capabilities are really great solution for customers to being able to kind of do self-managed restore and so on. Or snapshots in general, even if you don't have a .snapshot access. Neither EFS nor Google File Store have snapshots at all, which is a big limitation, I think. Some others do have some snapshots capabilities, but not all of them. Availability is, again, from what I've seen, the SLA where it's defined, it's even lower than for block storage. Yes, the durability here is much higher because of usually it's replicated between different availability zones and so on. But availability is not committed. There are differences in performance, different performance tiers to improve the cost of the capacity of the storage. And there are some differences in the protocols available from different vendors, but it's always NFS and or SMB in one way or the other. So again, basic things are usually there. If I look on the enterprise functionality, and I didn't have time to put in the Oracle and Alibaba thing, so it doesn't mean that they don't have anything. It just means that I didn't pay enough attention to them. But I looking on the others, I guess they also probably would be more red than blue here. Read-write snapshots, no. Consistency groups, no. Replication, somewhat, right? Again, natively, yes, I can do rsync and replicate between one file system to the other, but this is not something that would be available directly from the file system. There are no things related to the controls of capacity or cost reduction. And even things like quota. So yes, you can create this unlimited file system in EFS. And that's great in some cases. But in general, the point is that I didn't see ever an end user who would care about capacity that he uses. So the data will grow instantly, and the CFO will get the bill for the capacity. This is great for the hypervisor, for the hyperscalers, but not as good for the IT administrators who basically should control the capacity used by the applications. Let's look on the performance. Yes?
What are the asterisks? Yes.
Oh, so basically what I mean here is that, yes, I can create an NFS mount to EFS over Direct Connect from on-prem or Azure file system. So yes, I can mount my file system through some kind of connectivity to on-prem.
Then why asterisk?
Say it again?
Then why the star? If you can, but what other limitations?
Oh, but you do need Direct Connect, for example, right? So it's not every customer has Direct Connect to his VPC. Yes?
You can use VPN also.
Can I do the NFS? OK, thanks. So, OK, no asterisk. OK, good. So let's look at performance. And again, the file systems in the clouds, they all are developed probably with some kind of thinking about HPC workloads that may be less interested in the low latency and more focused on the throughput. And also a massive amount of clients accessing the data. So if I have a very large file system, if I have many, many, many clients, and I run this massive workload, I probably will get a good throughput, especially with some of the implementations, not all of them. But if I want to run a test on a single client, a single instance, I will get into the limitations very quickly. So the differences between those three cloud providers that I tested here, they are so big in performance that I had to use log scale for the graph. So unlike the block storage performance that I showed, here this is a log scale. And the main, so you can see basically what I get, and I also put the numbers, the actual numbers here. It's interesting to see the difference in latency, especially with reads and writes, with the different providers. One thing that was interesting is that Google's solution is probably the least scalable from the kind of capacity point of view, definitely comparing to EFS. But if you're talking about a single instance performance, it provides much better performance. Yes, if we go to thousands of clients, then EFS becomes much better, yes.
So why 4K random rate at 107 to 64 random rates is 99%? They don't like 4K small blocks?
So I guess that's a question to the EFS guys behind. But yeah, I don't think it's tuned for the small scale write, for the small block writes, for sure. That's, yeah.
So in a normal performance curve, if you're doing ops on the x-axis, latency on the y-axis, you'll go for a while and you'll hit a hockey stick. Where are you in an ops on the standard ops latency curve when you're showing us? Are we past the latency hockey stick and we're way up on top, or are you in the middle somewhere?
So I did not run like multiple points collecting the building graph. What I was doing is I said, OK, I have some basic VDBench configuration. I'm going to run the same configuration on GCP instance with the file store and M410 extra large instance in Amazon with EFS and so on. So I didn't want to get where exactly that becomes this way. Just wanted to see what do I get if I run the same workload on 3 of those.
I'm not super familiar with the implementation of all these, but I think at least one of those cloud providers will start throttling you if you go past the ops that you have to pay for.
Absolutely.
Are you in the throttling
So, and specifically with the EFS, yes. So the capacity, or performance that you get, unless you pay for the provisioned throughput, you get based on the capacity used within your file system, right? So I think it's like 100 megabytes a second for every terabyte used or something like that. And if the amount of space used within the file system is low, you'll be throttled pretty quickly. And that's exactly what might be here.
Some of that is a little punitive, so that it's not just throttling, it's throttling with an enforced delay to encourage you not to go beyond those caps.
Mm-hmm.
That may be part of what's happening here, is that you're getting punished for asking for too many hours.
All right. And there used to be a case when basically the recommendation to improve performance on EFS was just to generate some junk data to increase the size of used space, and then you get more throughput. Now with the provisioned throughput, it's better. At least you don't have to generate the junk. It gets generated automatically, I guess. But anyway, so looking into the IOPS, again, that's very true. It depends really on the implementation of the file system. And some implementations, like, again, with EFS, you are limited by the capacity used. With Azure and Google, it's different. But the overall scale of the solution is very different, right? We saw that with Azure files, until now, the GA version supports up to 5 terabytes per file system. With Google, I cannot grow beyond 64 terabytes per file system. With EFS, I have no limits. So it's very clear why the decisions were made differently to support this scale. But still, especially if you're not talking about multi-terabyte file systems, you have to be aware of those limitations. And again, throughput, EFS is very different. The more you store, the more throughput you get. I was able to get, with different tests, to multiple gigabytes a second throughput with EFS. But again, that depends on the size of the file system that you use. Let's look on the cost. So most of the providers have several tiers, or kind of high-end tier and the low-cost tier with the file systems offerings. This is way more expensive than the block storage, usually. Both are. However, it's also understandable. There's definitely much more redundancy that's usually replicated between multiple availability zones and so on, which also has impact on the latency, right? If the EFS data is synchronously replicated, I guess, between different availability zones, there is a cost related to the latency. So the cost here is, again, talking about somewhere around the 30 cents a gig. Yes, this is a used capacity, not allocated capacity, which is kind of better. But still, it's very expensive. If I translate this into, again, the cost of upfront payment that the customer would make buying similar capacity on-prem, that becomes way more expensive than buying just a regular NAS system, usually. Now, yes, it's not exactly apple-to-apple comparison, because here it includes not only the actual acquisition cost, but also the operational cost of the system. But still, the numbers here going into, well, I'm not looking at IBM with $17 million, but $10 million and above, that's kind of too much for a petabyte. So again, performance is limited, especially if you're looking at the performance per single instance. And the reasons why it's limited varies significantly between clouds and between implementations. Basic functionality is also there. Enterprise features are not. And the cost is way higher. Object storage. I didn't want to compare object storage features because, first of all, object storage is still very foreign for the enterprise on-premise workloads. They're usually focused more on the block and file. And looking into the object storage more as kind of archive tier as opposed to any kind of primary tier of storage as happens in the cloud. So I didn't want to look into the functionality. I just looked on the cost of storage. right? And I looked on the standard tier and the low-cost tier. I didn't look into the archive storage in the cloud, so no things like Glacier or cold storage in Google and so on. And rumor has it that the object storage in the cloud is cheap. Is it? This is only the storage cost, right? So how much will I pay if I buy 1 petabyte of object storage for 3 years support? However, it does not include things related to the access, the number of requests, which are charged separately. This is just keeping the data. And even keeping the data, yes, it's cheaper than, significantly cheaper than file and block, but still the pricing here going into kind of $700 per terabyte and above, that's expensive. And again, that does not include the cost of access. So let's look at the total cost here. And I took just an example of Amazon, right? Looking into the standard cost from the US East. This is what I pay per gigabyte store, depending on the capacity I use. But then I have to pay for the requests, right? And for every 1,000 of requests, depending on the type of request, I have to pay. If I access the data from outside of Amazon, I have to pay for egress. So let's assume I'm taking this for 3 years runtime. I'm buying 1 petabyte of capacity. And I do relatively low for the petabyte of capacity amount of requests. I'm talking about 200 puts a second and 500 gets a second. So it's really nothing. Just this amount of requests and 0 egress. So it's all consumed within the cloud. Even with this amount of requests, I'm getting to over $100,000 just for the accesses. If I'm getting into anywhere higher, which would probably be the case for a petabyte of capacity, this number will be much higher. So again, looking on the cost of the object storage, it seems to be lower. But if you look into the overall cost, including the access and requests, it's not necessarily so. I can read. Yeah. Want to do it?
Switch on me too fast. The blur there. Thank you. The slides will be available.
Yeah, it's all available.
It's not in the slides. It is.
So they should upload. Yeah, so there is a newer version that should be uploaded. That includes some of the things. So object storage is definitely the cloud storage, right? If an application was born in the cloud, it will probably use cloud storage. Well, in most of the cases. It still has a limited adoption on-prem. It probably will change as more and more ISVs write things that expect object storage. But it's hard to compare with enterprise expected set of features because there is no such. What is definitely clear from this is it's cheaper than the block and file storage in the cloud, but it's not that cheap. So
Did you do any look at really cold storage?
No.
Or do you have any thoughts on that?
No, I didn't calculate this. I could do some kind of comparison with whether Glacier versus Data Domain or INFINIGAT or any kind of things, but no. So this is an interesting thing. This is a real summary from our customer. They have over 20 petabytes of our storage on-prem. And they are thinking of migration of the environment into the public cloud, one of them, one of those major 3. So vendor is INFINIDAT. I didn't want to talk about that. And cloud is one of the clouds. Doesn't really matter. But this is an internal analysis that the storage team within the company made, looking into why migration to the public cloud would be problematic for them. And this is basically what I showed. So things that they expect and see them as granted on-prem with INFINIDAT storage or probably with our competitors, they are not available in the public cloud. So this means for them that just taking the application, moving it as is into the public cloud is not possible. They either have to do some kind of development work and modify the application, which they may or may not be able to do, or they won't be able to do this migration at all. Okay. So there are solutions that are available from us, and there are some competitive solutions as well that allow you to consume enterprise storage within the public cloud or adjacent to the public cloud. So from our point of view, we provide a managed service using our storage adjacent to public clouds with connectivity to all major hyperscalers today. Customers can do either replication from on-prem to what we call the Neutrix cloud and use this as a kind of remote site for disaster recovery purposes or any other reasons. They can also access this data from the public cloud, and they can access this data from multiple public clouds at the same time, if they care. So we can create an NFS file system and make it accessible from both Amazon and Azure and share data if the customer is interested in multi-cloud. Or this data can be used just within a single cloud. It can be replicated between different regions. It can be replicated between cloud and the on-prem environment. And it provides this extra functionality that the customers expect with the on-prem storage. There are some limitations considering the distance, right? So it's not in the cloud environment that we have up to 3 milliseconds latency between the public clouds and our capacity in general. But the functionality that we talked about, whether it's replication, whether it's snapshots, quotas, everything that the customer expects to get from his storage on-prem is available also for his instances in the public cloud. Again, I used here our example. There are some solutions from our competitors that are trying to address the same type of limitations available in the public cloud today and offer this extra service to the customers. One thing that is not available, and I don't expect this to be available from the hyperscalers anytime soon, is an ability to really share data between the clouds, right? And allow workloads to really run across multiple clouds for various reasons. So to summarize, we see that definitely clouds have very rich set of offerings related to storage, whether it's block, file, or object. They are developed for applications that are not expecting high availability from the infrastructure. So things that are defined as kind of cloud native, and those that are expecting the availability and reliability on the application level, not on the infrastructure level, they'll do just fine in the cloud. Native enterprise applications developed for the on-prem deployment, those that have expectations from the highly available infrastructure, either need some changes or require solutions that are not available today in the public clouds. And that makes this lift and shift approach for the enterprise really complicated. And it gives a major area for improvement for public clouds and also gives an opportunity for enterprise storage vendors to offer something that provides extra capabilities for the customers. Questions?
So if I have a volume shared with instances in the Google Cloud and I want to move to the Amazon Cloud and move the workload to the Amazon Cloud and still use the same data, do I need to do anything or it will just mount on the other cloud?
Oh, you mean with the Neutrix?
Yeah.
Yeah, so no, you don't need to move anything. Well, you have to move your application, but if your application is portable, all right, so for example, we have customers who run containers workloads, and they can do this between Amazon and Google and Azure, and the data is available, it's shared, so they can consume this. And one of the use cases that we see for this multi-cloud setup is an ability to get kind of the lowest cost of the instance. Right, you can apply for the spot instances in Amazon or similar capabilities in Google and Azure. You can, as long as the data is available across all three of those clouds, you can bet always for the cheapest instance at any given time in any of those clouds and then just consume your data.
You're never locked in.
Right, so that's just one of the examples of why it's interesting.
Wouldn't you have to pay for the inbound data in each of those clouds every time?
So there is a cost of egress. Yes, but depending on your workload. So if you're If you run a workload that is doing mostly read, then you don't have an egress cost. If you mostly read the data from this cloud, right, it's large scale processing of some kind of data, then it's economical.
The cloud at the bottom does not have a.
No. Right, so what we, well, if we talk about Newdrick specifically, right, so we do not charge for egress, we do not charge for, we don't charge for traffic, we charge only for capacity. It's 9 cents a gig a month for both block and file, and snapshots are free unless you make changes and so on. It's all available on our website. We can talk about this after the talk if needed. But yeah, so we do not charge for egress. There is an egress charge that all major public clouds may introduce, but we do not charge anything on our side.
And who pays for the link to your cloud?
You mean this or this? Or this?
The link, yeah.
So for the replication.
Yeah, for the replication.
So we basically provision the capacity for the replication on our side. If a customer needs some extremely high bandwidth, we should talk about it. But usually, if we're talking about gigabit a second, plus or minus, that's something that we just give capacity. Now, the customer has to pay for his side of the internet connectivity, obviously, to get this connection. But that's his side.
And the connectivity to the other clouds at what speed?
So it depends on what the public cloud provides. We do direct connect to AWS. We do express route to Azure and so on. And it depends on really the bandwidth that is supported by the public cloud providers. It may vary. Other questions? Okay. Thank you.